Hello guys, I'm very excited to start this new series of data science. Today the first thing we are going to learn is what is simple linear regression, and I'm not going to go deep into the math or the stats part of it, rather I'm going into the implement part of it using Python. So what is a regression? Regression is nothing but finding out or predicting a value using the previous values, right? So why is it called a simple linear regression? If you look at a plot like this, so these will be your data points. So we have two axes here, and these are your data points. So if you draw a straight line which best describes these points, you will get a simple linear regression. And now if you want to predict any value, you just have to find that particular value, let's say 50 in this case, and drop a perpendicular line onto this horizon or onto this linear regression line, and that point where it meets that line will give you this value on this vertical scale, and this will be the value or the predicted value for that x variable. So let's get into the hands-on experience with Python and we'll get to know more about this. So for this we are going to use Anaconda, and you can use any interpreter of your choice, but I'll stick to this Anaconda because this is how I learned. And you can launch a Spyder over here. This is a scientific development environment. It's a very powerful IDE. You can do a lot of stuff, basics of which I'm going to show it to you. I've already written the code. First, what you have to do is go to File Explorer, go to the place where your files are, Simple Linear Regression, and now you have set your environment. This will be your IPython console where your code will be executed, and Variable Explorer you'll see just now. First, let's import all these necessary libraries: NumPy for NumPy arrays, Matplot for plotting, and Pandas, of course. So using Pandas will import the data set. And if you double click on this Variable Explorer, you can see the data set as it is. So this data set has years of experience. Index you can ignore, but note that index starts from 0 in Python, not 1. Coming back to the data set, years of experience, you can see here is correlated to salary, and that is what we have to find out. Using this data set, we have to predict, given particular year, what will be the salary of that particular person. Doing it in Python is very easy. First, you split the data into x and y variables. So x will be your variables of age, and y will be your predictor, that is salary. Next, what we are doing is we are splitting this data into test and train split using this test train split module. So let me add it into a single line so that it's visible. If you press Ctrl I over here, okay, you have to execute this line so that it imports the module. And now if you press Ctrl I, you will find the help window on your right side. So here you can see what are the parameters that you can pass and all the details related to it. So we have passed x and y, which is what you want to split it, and the test size, which is 1/3 of the total size, and the random state. So though we think that this is going to split randomly, internally in Python it's not going to split it randomly, but it's going to do it on a particular state. So for if you want to have the same results like I am having, I suggest you set this to 0. So all of us who have set this random state to 0 using the same data set, the split is going to be constant or similar. Ignore these values comments for now. We'll get into that when it's required. coming to the important part of linear regression, how to execute it. So sklearn module or scikit-learn has this linear regression module, and this is where you initialize it into a regressor. Next you have to do is you have to fit this module using the fit model, but it says that xtrain is not defined, and this is because we have not executed this particular line which actually splits the data. If you go to variable explorer, you can see the data now, xtest and xtrain over here. Xtrain normally has more data because that is where your machine learning algorithm is going to learn. And now if we try to fit the data, and it should fit it, this is where you are going to predict the value. So why predict? These are the predicted values, and if you actually match it with your test values, they should be at least closer to each other. That is what you can find. So we have a good linear algorithm here, which is almost, for example, this ninth value is 100,000 and it's 101,000 here. So it's a pretty good fit, but we can visualize this and come back to our Python code over here. Plot is basically from the plot library matplotlib. So if I execute this particular plot, I will host this code and you can definitely find out how to execute that, and you have this beautiful plot, and this is your trained data. So these red dots you can see are the actual training data that you have, and this is your regression line. So your regression line is nothing but y is equal to, let's say, a constant, you can call it b0 plus b1 into x. So x is your independent variable, and y is your dependent variable. In this case, salary is your dependent variable and years of experience is your independent variable, and the b0 is basically, it's a point where it's going to cut this vertical axis, and that is the intercept, as you can see, and b0 plus b1x. So b1 will be the slope of this particular line, and it's linear regression because there is only a straight line which is drawn or fitted into this. How this line is fitted into the algorithm, how this line is fitted into the data is based on the algorithm, and mostly the algorithm uses something called as minimal sum of squares errors. So not getting much deep into this theoretical part of it, quickly if I have to summarize it, so some error is basically, if you had to plot a point at the age of experience of 6 years, and if you had plotted the point or predicted the value, you would have got a dot over here instead of getting a dot over here, which is the actual value. So now this difference between these 2 points will give you the this difference. If you square it, will give you this square of the difference. And now if you find all those squares of those distances and add them up, you will get the sum of squares, and this line is fit such a way that you will get the minimum sum of squares. And you might be wondering why it's called simple. That is because you have only one independent variable over here, and in future you will see multiple independent variables, and your equation is going to grow complex. So that's all about linear regression. Before going, I just want to show you another plot which is actually fitting the data of a predicted train value. So train value against the predicted value. So here what we had, okay, my bad, I am supposed to show it against, yeah, I have done that against the test value. So let's plot the graph. There you see it's pretty much neatly fitting the line except for these few errors, and that is all right, because if it actually goes through each and every point, that will be an overfit, which is a concept we'll discuss in the future. And this is a very neat data set, and I believe this is not what you're going to get when you're actually doing the data. analysis. So I hope you enjoyed this tutorial. Looking forward to talk to you next time. Thank you for watching.